So we went over classification and hit rates, your Wilks lambda, right?
All right, so do you guys know the purpose of discriminant analysis? Okay, it's used to predict group membership.
Canonical correlation.
Yeah, but what it is? Okay, so Sarah. Huh?
I don't know the purpose of any of this.
You just gotta memorize it. No, try and understand it. And then memorize it. And then next year, or in 3 years, when you go to do your dissertation, you'll be like, oh, I get it. Okay, discriminant functions. So discriminant functions are how you create the equation. So some of these functions include the structure matrix, and structure matrix test for significance. They cannot be compared, and they're like the loadings for factor analysis.
What did you say right before cannot be compared?
They test for significance. Okay, so that was structure matrix. And then we've got standardized betas, which can be compared because they're standardized, right? You can compare stuff that's standardized.
Are we under discriminant functions?
Yep.
Structure matrix and then
Structure matrix, standardized betas. Then we can do canonical discriminant function coefficients can fit here too.
that's a discriminant function.
And then I have written group centroids. And those are just the means of the groups.
Those are all under structure.
Nope, that's all under discriminant functions. So if discriminant functions is your main heading, then you've got structure matrix, standardized betas, canonical discriminant function coefficients, and group centroids. Okay?
Are these like types?
Yeah. Yep. So,
Paper for this test.
huh? So canonical correlation, okay, that's the next bullet, and the next term.
I'm sure people understand I didn't organize it properly the first time.
Okay, so discriminant functions, and then there's 4 examples. Structure matrix.
Okay.
Second example, standardized betas. Third example, canonical discriminant function coefficients. Fourth example, group centroids.
Under the canonical discriminant functions coefficients. Right now.
No. There were 4. Good?
And the group centroids are the means of the groups?
Yep. So, canonical correlation. This is the percent of variance that discriminant function accounts for. This is the one that you need to square for the percent. Okay, once you square it, it's like that R squared. Percent variance that discriminant function accounts for. Okay. Just don't forget to square it for the percentage. He likes to ask those kind of questions. Okay, and one more thing for this is that it's a multiple correlation between the predictors and the discriminant function. Between the predictors and the discriminant function. Okay, so next, canonical discriminant function coefficients. So if they're raw, they're unstandardized. Okay, these give you the weight for each function. It helps you create your equation. They're just like the raw regression weights. And when you're looking for these in SPSS, they're actually called canonical discriminant function coefficients. Okay? Which was like the title of this subsection of this term. Okay, and then standardized. Again, because they're standardized, it allows you to compare variables measured on different scales. They're like beta weights. And with these, it's hard to test for significance. Way to do this, right?
When we discussed the canonical correlations,
Mm-hmm.
those are not included as a type of discriminant function.
It was the canonical discriminant function coefficient that was a type of discriminant function.
Right, so then the
Canonical, just its own term. Yeah, because it's like an R. It's either like an R squared or a Pearson R.
It's a Pearson R until you square it, which then is the
Yeah.
variance.
How do you know which ones are standardized and which ones are raw?
The raw are the ones labeled
Structure.
canonical. These are the raw.
Yeah.
Canonical different function coefficients are the raw, and then the standardized say standardized. Okay?
Canonical discriminant function coefficients, those are the raw,
Yeah.
and then above, standardized ones. Okay.
Yep. So if it doesn't say standardized, then it's raw. Do we do structure coefficients yet? Before? Okay. This is the correlation of each predictor variable with a discriminant function.
Structure coefficient.
Yep, structure coefficients. It's the correlation of each predictor variable with a discriminant function. Okay, these can be tested for significance. They cannot be compared. And they're similar to the loadings in factor analysis. Okay? Wilks lambda. Okay, so this tests the significance of the function. It's the measure of how well each function separates cases into groups. This one sounds important, doesn't it? Okay, here's a long one. Ready? It's Wilks lambda still. It's equal to the proportion of the total variance in the discriminant scores not explained by differences among groups. So it's the percent of variance not explained by the model.
only use the canonical correlation if your Wilks lambda is significant?
Is that what he said in class? Or were you reading that?
Somewhat connected.
Where are you reading that?
Output tables. Second page. On the bottom summary of canonical discriminant functions.
1 squared percent of variance that discriminant function accounts for, like an R squared. I think he's just pointing to the significance. He wants you to see that it is significant.
We want it to be significant or not?
The Wilks lambda?
Yeah.
Yeah. Yeah, because it tests the significance of the function. All right, and then discriminant score. So everybody's good with classification tables, assumptions. It says C Manova. You guys good with that or no? Okay, we'll go back to that in a second. The discriminant score. The predicted outcome. It's comparing against the actual outcome. It's generated for each subject. And it tells you which group you think they'll fall in. Okay, and sometimes this is called the predicted value. So here are the assumptions.
So for the assumptions, he does a pretty good review of the assumptions in the slides that he gave you in class this last Wednesday. Just wanted to point out a couple of things. So homogeneity of variance, covariance matrices. In a discriminant analysis, it's really sensitive.
And you do not want significance.
Yeah, you used, to test this one, this assumption, you look at boxes M, which is easily violated.
What is this for? Yeah.
These are the assumptions of discriminant analysis, and this is particularly the homogeneity of variance covariance matrices. So to evaluate that assumption, you look at boxes M, which is easily violated. And that's the one where he had the two boxes. One was the likelihood that the effect exists, the one where it's due to chance, right? He had the 0 and the 1, the predicted. And you want the correlations between the two to be similar.
Normality and multicollinearity.
Yeah. So one last thing about boxes M, it's robust against normality, but not homogeneity of variance covariance. So if you have it, if it's violated, you want to check other things like skewness or look for outliers. Huh?
If everything else is okay,
Well, when you're talking about normality, but with homogeneity of variance covariance, again, you want to check all of your other assumptions. So your F max, you want to look at that. Boxes M is another way that this is going to show up though. But if it's violated, it could be due to having the presence of an outlier, having skewness, which if you correct, then it may correct boxes M. So you can do these other things to figure out if you can get boxes M to be corrected. Yeah.
Yeah, read through this packet. Some of the assumptions are old, like linearity, independence of observations, some of the stuff you know. Normality, the
discriminant. discriminant analysis handout that he gave you on Wednesday with the slides. And so the last thing is, he said that there's going to be a lot of logistic stuff on here, on this exam, so pay attention to logistic. And you'll also want to be able to know the differences between some of the tests. So remember how we talked about the differences between logistic and discriminant? You'll want to know those.
Between the different types.
And what
Like
they do.
What they do, why you would choose one over the other. Same thing with ANCOVA and the other options, so like treatment by blocks, you know, that kind of thing. Okay.
So for that, we recommend a decision tree.
Yeah, you could review your decision tree, but we went over all of the differences. When we went over logistic, we hit on some.
I recommend flashcards
All right.
for some of the, like, what you need kind of things.
And then I'll ask him about scores saved, and then what was the other one we were gonna ask him about? Right, with the EXPB, he actually talks about it in the logistic slides.
I know, it was like the 1 minus the odds ratio.
Oh, 1 minus odds ratio, thank you.
Again, be familiar with the classification table. Those could be really easy questions to get right, since you're already learning in another class. Okay. Bye. Sure. Sorry,